Hey there, so we're doing another crypto challenge from the Cyber Apocalypse CTF 2022. This time we're going to be doing Jenny from the block, which here is the information if you want it. And the cliff for this challenge is basically just the encryption process is the addition of 2 bytes together. So to decrypt, we're just going to reverse that and subtract 2 bytes together. And we're able to do this because we actually can know the entire first block based on what we've been given. So we have source code for this. So if we jump in and look at it, we see that basically we connect to a challenge server and it's just going to let us know that all the responses are encrypted. Essentially, it's allowing us to execute a command from this list of commands. Clearly the one we're going to want here is probably to cat the secret txt. And then it runs that command, which is just basically running it in a subprocess. So, it'd be like if you were typing it in the shell. And the output from that is going to get concatenated with this expression, the command that we typed, a new line, and then the output. And it's generating a random 32-byte password. And it's sending that output and the password into the encryption function. And then it's going to send us that in response. So actually, if we go ahead and let's just connect so we can show what this is. Make sure I have it copied. So if we look at it, we want to cat the secret txt. We see we just get this big hex output. So if we look at the actual encryption process, that random 32-byte password, which is what's getting inputted in with it, is just going to be hashed. And then it's making sure the message is divisible by 32 bytes. If not, it's going to pad it. And then it's basically going to carve that message up into blocks. Each block is going to be 32 bytes long. And then each block, it's going to encrypt the block by passing in the block and that H, which is the hash of the password, into the encryption function. And then the next round through, that H is going to be the hash of the encrypted block and the plain text block. And it's just all going to get added together, and that's what they're going to give back, which is basically what this is. That's the hex output of that. And if we look at the actual encryption function, we see it's just adding together each byte in the message and what that secret value is, that H, each byte from that hash. And that's modulo 256. But I don't really have to worry about that in a sense, because secret is the output of the hash. So this could be any byte from, any value from 0 to 255, but the block we're outputting the secret text, which we assume is just a file that, contains normal kind of ASCII characters because we're going to read it. Hopefully it has the flag in it. So really the block here kind of has a maximum value of 120. So it's not like we're looping around this a bunch of times. So like the max we could go is just over it. So we can actually just subtract to decrypt. We just do this backwards. We can just subtract. If we end up with a negative number, that's no big deal, because when you do like the -5 modulo 256 should just be 251. So we can easily recover from negative numbers. So essentially, it's pretty straightforward. The only thing we have to concern ourselves with is we need to know what, in order to get this H, either we need to know what the hash of the random 32-byte password is, which is essentially impossible. How could we know that? But if you look the next round through, the hash is going to be the encrypted block, right? We have every block of the encrypted thing. Like, we were given that. So if we somehow knew an entire block of plain text, like say we knew the entire block of the first plain text, then what that would mean is the next time through we would know what H is, right? Because we have the first block of encrypted output. So if we knew the first block of the plain text, the next time through we would know what H was, so we could decrypt it because we have the encrypted block and then we would have the secret. Well, let's take a look at what the output actually is, right? We've got command executed, a space, plus the command, and then plus this new line character. Well, if we look at this, let's just start out with that. We'll just block 1, right? Well, right now it is already 18 bytes long, but if you look at the command we actually want to execute, this over here. Well, if we're adding cat secret text to it, looky what we get. That's 32 bytes, which means we know the entirety of the first block of plain text because it's going to be command executed, cat secret text, new line, and then whatever the output is. But we have an entire block, which means we can just get the H for the second block. So with that in mind, we can go ahead and, oops. The solution. We can just go ahead and write our decryption function. So we know, we just do this in the terminal too, but we know the output. Oops. We know the ciphertext is that. So let's just go ahead and write a decryption function. So let's just say decrypt. Well, we're basically just going to reverse this, right? So we know the first byte of, or the first block of plain text is, or we'll do everything in bytes. What was it? Command executed cat secret.txt. And then we want to carve up that ciphertext into blocks of 32 bytes. So we will say ciphertext blocks. We'll use list comprehension here, and we'll just do basically the same thing they did there, where we will say ciphertext I plus 32, or I in range 0, length of the ciphertext, and we'll jump 32 every time. And then we know we want each time through that H, I'm going to have to import hashlib. So we want the SHA of the first block of ciphertext plus the first block of plain text, which we can just use plain text, right? Because we know that's exactly 1 byte long, or 1 block long. And we want the bytes of that, which is what digest does. It just gives you the bytes. So then we can actually go ahead and start undoing it. So for each block, now we don't want to do all the blocks, right? Because we know what the first one is. So we want to start on the first block and then do all the rest. Like we're essentially skipping the first time through because we don't know the password, but we don't care because we have the first block of plain text anyway, which allows us to get the H for the second time through. So we're not looking for the first block. We're starting on the second block. And then, oops. Okay, I've got something wrong here for CT bugs. Why is it not? No. I'm going to have a bug somewhere. Sort that out later. So our first block through, right? This is where we'll actually do the decryption like how they were doing here where they're adding, but instead of adding, we are going to subtract. So we'll say we want, let's see here, we want to do A minus B, and we're doing that modulo 256 for a B in zip block and our H, right, which is essentially, this is just a, well, list comprehension way to do this, right? We're going to go through each one and we're just adding them together, modulo 256. So to decrypt, we'll subtract them modulo 256. So this here will give us an array of the byte values of the result. And since we actually want a byte string, we can just say this is in bytes. And then we need to get the H for the next time through. So that will be the encrypted block plus the plaintext block we just discovered. And we want that in bytes. And then we're adding that to the plaintext. And then we're going to return the plaintext. And that should give us the flag. Actually, so we're doing bytes. Let's go ahead and do it here. Actually, let's do it on the next line. CT equals bytes from hex. So now that's in bytes. It's getting passed in. This is in bytes. We're carving that up into blocks. I feel like I have a bug somewhere, but let's just YOLO this. So we will say our flag is we're going to decrypt the ciphertext, and then we're going to print the flag. And let's see what I screwed up. All right, what did I do? For ciphertext block and ciphertext blocks. We're getting the same block every time. I feel like this is probably obvious if you're watching this. Maybe you're like screaming at the monitor. You idiot, it is. Oh, here's what I did. So I was just adding that plain text to it each time, and I want to add that plain text block we just discovered. So let's try this again. There we go. So that is the output. This was the secret file, or secret.txt, and there is our flag. So there you go. Hopefully that made sense. I didn't screw that up too terribly awful. Yeah, if you have any questions, nothing made sense, please leave a comment. Or feel free to leave a comment. If you actually made it the whole way through this video, I appreciate it. Thank you for watching. I hope you got something out of this, and yeah, take care.